Hi, we have already discussed on the lexical analysis and syntax analysis. Now, if you remember your YARC program, you already had a set of productions, and for every production there might be some actions which has to take place. These are termed as semantic rules. Now, any set of productions which has a set of semantic rules along with it, we call it as a syntax directed definition. We are supposed to understand what those definitions are and how are we going to represent the different evaluations which can take place, and what are the evaluations which can take place that can be represented in a syntax directed definition is explained in this video. So these things we call it as semantic rules. Now moving on to the definition, for every set of productions you can have certain semantic rules such as evaluation of the grammar symbols, converting them to an intermediate code generation. There are examples where you can do and type checking. Where do I do and type checking? I do and type checking during semantic analysis. So as and when syntax analysis checks the format of the program, parallelly we can also do an analysis, or you can do an data checking and check whether there is any type mismatch, and there are much more to talk about. So for every grammar symbol, especially for every non-terminal, we have certain attributes which are attached to them. Now what are the attributes called as? The attributes can be the value, the attributes can be the type. Maybe for example, we'll just take an example and see how it works out. Now here you have something called as E produces E plus T. Now this E suffix 1 is to just differentiate the instance. Now this grammar we already knew it from our predictive parsing and your LALR parsing concepts. So this is a grammar which tries to evaluate the set of arithmetic operations which has plus and star. So now what are we supposed to do? Every grammar, when I take a digit, now this digit can be a decimal number, can be an integer, can be a negative number, so on and so forth. So they have a data type. If you remember your programming language concepts, you have different bytes which are being allocated for different numerical data types. We have different bytes for int, unsigned int, long. You have a minimum value, maximum value which is accepted. That is, you have a range where we accept these values. So all these act as the attributes. So now when I say f is a digit, digit has some value. Maybe you say 5 plus 6. So what happens? The value digit first takes in 5. So that is taken as a lexical value. Now this is an attribute for a digit. When you try to reduce digit 5 to f based on your LR parsing, the value 5 associated with the digit gets mapped with f. So these are the attributes what you talk about. So now there are many attributes which we talk here. So value is one such attribute. Now you have two different type of definitions. One is the syntax directed definition and the other one is the translation scheme. Now what is the difference between syntax directed definition and the translation scheme? Both syntax directed definition, which is abbreviated as SDD, and the translation schemes have a set of productions and have a set of work to be done, actions to be taken for every production. It can be one action or more than one actions. But then if there is any implementation details which are provided in the semantic actions or the semantic rules, then the definition is termed as a translation scheme. Or else any evaluation of an attribute, we call it as a syntax directed definition. So that is what they have given here as high level specification for the translation. We know the order of evaluation, in which form it has to be evaluated and so on. But then if there is a set of implementation details which are provided, then you call that SDD as a translation scheme. Now, how do I define it? You have certain informations which are attached to it. So now for every production, we'll take a production and see how it works. Here we have a set of production where it evaluates some value 5 plus 6 and prints it onto the console. So now, having said this, how are we going to evaluate it? Here we have something called as 5 plus 3 star 4. So this is how we are going to have the parse tree. We'll say the 5 is the digit. When it is reduced to f has an attribute called as value, for which the value 5 is assigned. Then f would be converted to t, reduced to t, where 5 of f's value will be placed onto t val, and then when reduced to e, the value, every non-terminal has val as an attribute, and therefore e dot val becomes 5. There you stop here, and then you read plus. Plus doesn't have any attribute to it, and then you go ahead saying 3 is taken to f is reduced to t, and here you take f. Why we stop here is because we have to evaluate t star f first. So we evaluated. Now when you see this node, when you combine t star f to t, the value of t and the value of f has been multiplied and is being assigned to t when t star f was reduced to t. And the same thing happens here. When e plus t is being reduced to e, the value related to e and the value related to t are being added and is being assigned. Now you have another node here. When you have e and then return, which means you have e and then you have an enter or you have a return statement, then you try to print it onto the console. Now what you really do here is a parse tree. You have a parse tree where you start from L, the starting symbol, and you have branched out to know how the derivation works, or from the root node to the leaf node to the root node, how the reduction works. But then what have we done here? We have given some values, or we have also shown the attributes of every grammar symbol. And when I add the attributes of the grammar symbol onto the parse tree, we call it as annotated parse tree or decorated parse tree. Now the process of adding the values to or the attributes to the parse tree is called as decorating or annotating. So that is what you talk about. Now you have a dependency graph. Now this dependency graph is quite interesting. So now what are we supposed to do? If only I know the value of this digit and the 3 digits, then I'll be able to calculate the value till L, or else I will not be able to. So here f is dependent on digit, and so you have an upward way of understanding things. F is dependent on digit, t is dependent on f. This t, before I know the value of t dot val, I should have known its child node's value, that is t and f. Similarly, before I know the value of e, I should have known the value of its child nodes e and t. And this is how the dependency graph is all about. Now coming on to all the definitions, a syntax directed definition is a generalization of the CFG. Okay. Now what every grammar symbol is associated with many attributes. You have seen only one attribute termed as val. You can also have attributes like data type. You can also have attributes like the range, and so on and so forth. So I have many set of attributes which are associated with one grammar symbol. Now these attributes can be classified into 2 types. One is synthesized and the other one is inherited. We have a semantic rule. We have seen how a dependency graph works, and all those are put here. And then we have seen what is annotated parse tree. Adding adding attributes to the grammar symbols, you call it as annotating or decorating, and once the parse tree is full of attributes, then you call it as an annotated parse tree. Now you have a syntax directed definition, where for every production, we are generalizing it. For every production, A produces alpha, we have some function which has to be evaluated. So we are taking it in general. Function f, which is based on its child node C1, C2, C3 and so on. Now I have already told you that the attributes are of two types. One is synthesized and the other one is inherited. Now what is synthesized attribute? To evaluate a parent node's attribute, we should know all its child nodes attribute. That is what a synthesized attribute is. Now given an example, to evaluate this E, I should know the value of E and T its child nodes. To evaluate the value of this T, I should know the value of T and F its child nodes. And therefore, such kind of attributes are termed as synthesized attributes. And therefore, they say B is a synthesized attribute of A, and C and C1 to Cn in general are the attributes of the grammar symbols of the production, its child nodes. Whereas B is an inherited attribute where you have to inherit either from your parent node or from the elder siblings. Elder siblings here in the sense the siblings which are left to you a particular node in the tree. Now for example, we have we'll just move for an inherited attribute. Now this is an example for an inherited attribute. Now what happens here is, first we'll understand what the context-free grammar here tells about. You have D produces TL. T is the type, and then you have, suppose you have int A comma B, and so on. All those are put in here. So if it is int A is the identifier which is made as a literal, T is the type, so you have int A as given here. Whenever you have an identifier, that has to be added onto the symbol table, and then therefore we have an add type pseudocode function which adds the information onto the symbol table. Now if you see here, symbol T is associated with a synthesized attribute, whereas symbol L is associated with an inherited attribute. Why they talk about every type T has to inherit its value from its child node, whereas L will inherit its attribute from the one behind it or to the left of it. So suppose you have real P and Q, which means real is the data type, P is the identifier, Q is another identifier. So what we do here is, from D it produces TL and real, and then L is divided into LID. You have two IDs here. Now from where will T take its value? T will take its value from its root node, that is real. So T dot real, it is given to L dot real. Therefore this is a synthesized attribute. Whereas here L dot real, this L will get its real value or the data type value from its parent, and it is passed downwards. Now if you see add entry has two parameters. One is this identifier, the second one is the data type. Identifier is obtained from the child node, whereas the data type is obtained from its parent node. Similarly here you have an attribute where you are supposed to pass in the data type. Now this data type is obtained from the parent node, which in turn is obtained from its child node. So here it is obtained from the parent node, or indirectly it is obtained from its left sibling, and therefore it is termed as inherited attribute. So that is what they try to say. An inherited attribute of the grammar symbol will be obtained from the it is an in alpha is obtained based on C1 to Cn, the attributes of the grammar symbols in the production A produces alpha. Now B will be the inherited attribute of any grammar symbol on the right hand side of the production, whereas here it is on the left hand side of the production. Synthesized, it is on the left hand side, whereas in inherited it has to be on the right hand side of the production. So this is the example for your synthesized attribute, whereas this is the example for the inherited attribute. Now this is the dependency graph for the example of inherited attribute. Based on the synthesized and inherited attribute, we have three definitions, attributed definitions: S attributed definition, L attributed definition, and not L attributed definition, which we will be discussing in the next video. Thank you.